By August 2026, the world hit a critical turning point. Traditional terrestrial farming has reached its limit. Years of extreme climate instability and soil degradation have crippled agricultural output. We are facing a global protein deficit that threatens our food security. The solution to this collapse isn't on land. It is beneath the waves, hidden in the untapped potential of the blue economy. Traditional agriculture is restricted to a horizontal plane, consuming finite land resources and relying on intensive inputs. Vertical ocean farming fundamentally shifts this paradigm. By moving into the 3D water column, we unlock vast, unused productive space. This system uses the full depth of the ocean, seaweed at the surface, bivalves in the mid-column, and bottom dwellers at the seabed, maximizing productivity without competing for land. Restorative polyculture transforms the ocean column into a high-yield 3D agricultural grid. At the surface, kelp forms a dense canopy, harvesting solar energy and absorbing nitrogen. Beneath the canopy, we utilize the mid-column. Suspended trays host bivalves like oysters, mussels, and scallops, which filter feed from the nutrient-rich water column. Finally, the seafloor serves as the ecosystem's vacuum. Sea cucumbers and clams dwell here, processing organic waste, ensuring that zero nutrients are lost in this closed-loop system. This architecture creates a balanced, restorative ecosystem that produces more protein per acre than any terrestrial farm, all while cleaning the surrounding ocean. Vertical ocean farming represents a shift toward a zero-input standard. Unlike land-based agriculture, it requires no external freshwater, pesticides, or chemical fertilizers. Traditional land farming depends on intensive resource inputs to sustain crop yields, placing enormous strain on freshwater and soil health. Conversely, our vertical ocean systems thrive entirely on existing nitrogen and phosphorus runoff from coastal ecosystems, effectively closing the nutrient loop. By integrating with the natural marine environment, we achieve a regenerative model that provides essential protein without depleting the planet's finite terrestrial resources. As the oceans absorb more atmospheric carbon dioxide, pH levels drop, threatening marine life. 3D ocean farms provide a critical defense mechanism. Kelp acts as a biological buffer. Through rapid photosynthesis, it absorbs local carbon dioxide, creating a higher pH microenvironment within the farm canopy. This shielded zone protects bivalves like oysters and mussels, which are highly sensitive to acidic water. Survival rates are significantly higher here than in open, unbuffered waters. This 2026 innovation ensures that bivalve production remains resilient, even as global ocean acidification continues to accelerate. Traditional cattle ranching is restricted by the limits of horizontal land. It is a 2D system. However, vertical ocean farming leverages the entire water column. By occupying the canopy, midwater, and bottom zones simultaneously, these farms reach unprecedented biomass density levels. This vertical utilization allows ocean farms to produce significantly more protein per acre, essentially closing the global protein supply gap that land-based systems can no longer address. By 2026, the industry has shifted from small experimental pilot programs to massive industrial-scale automated grids. Autonomous underwater vehicles, or AUVs, now work in tandem with robotic kelp cutting arrays to manage these complex 3D farms. This transition to total automation has reduced harvesting costs by 65% since 2024, making marine protein price competitive with traditional livestock. The Cascadia Vertical Hub in the Pacific Northwest represents a milestone in large-scale ocean agriculture. Spanning 500 acres, this automated grid has successfully transitioned regional protein supply chains. By moving away from land-intensive soy production, the hub produces high-protein kelp powders and refined bivalve extracts. This proof of concept demonstrates that marine protein is not just viable, but economically superior in the 2026 market. The Cascadia case study confirms that modular, vertical farming can sustainably replace legacy agricultural footprints while providing a reliable protein source for the growing population. Precision fermentation is the cornerstone of our protein transition. We start by taking raw seaweed biomass, rich in essential minerals and amino acids. This biomass enters industrial-scale bioreactors, where specialized microbes break down complex carbohydrates and proteins at the molecular level. Through controlled environmental parameters, we retexture these proteins, transforming them into products that mimic the sensory profile and nutritional density of traditional beef or poultry. This process allows us to create savory, high-protein food staples directly from marine resources without relying on land-based livestock. The seaweed-to-steak movement marks a paradigm shift in food science. By leveraging precision fermentation, we are no longer just farming ocean biomass. We are architecting it. Scientists use precision fermentation to extract proteins from kelp. These proteins are then restructured at the molecular level. The result is an umami-rich burger patty that perfectly mimics the sensory profile of beef. This innovation makes sustainable marine protein a mainstream commodity. Marine biomass has officially moved beyond the health food niche. In the span of just a few years, it has transformed into a global food commodity. Previously relegated to boutique specialty markets, it is now a cornerstone of mass-market fast casual dining. Fast casual chains now standardly integrate ocean umami burger as a core menu item. Fast casual chains now standardly integrate kelp-based tacos as a core menu item. Fast casual chains now standardly integrate protein-dense bowls as a core menu item. Marine protein has successfully shifted from a sustainable alternative to a structural pillar of the modern global diet. Vertical ocean farms in 2026 have evolved into multi-revenue engines. Beyond harvesting biomass for food, these operations capture and sell verified blue carbon credits, creating a diversified economic model. Kelp is a biological powerhouse. It absorbs massive amounts of CO2 from the water column, sequestering carbon permanently as it grows. This natural process is quantified, verified, and turned into tradable credits. By subsidizing the base production costs through these credits, ocean farmers can lower the final market price of marine protein. This makes sustainable seafood a direct competitor to terrestrial livestock on price alone. This economic integration makes marine protein not only the most environmentally sound choice, but the most affordable source of protein for consumers in 2026. The environmental impact of traditional beef production is staggering, requiring 15,000 liters of water and up to 15 kilograms of grain for every single kilogram of meat produced. In direct contrast, vertical ocean farms require absolutely zero grain and zero freshwater. This represents a fundamental shift in our resource efficiency paradigm. By mid-2026, economic data confirms a major turning point. Vertical ocean farming has successfully closed 18% of the global protein deficit. This supply shift is not just an economic metric. It provides essential, high-density nutrients to vulnerable coastal populations, significantly stabilizing food security and curbing the risk of civil unrest in nations most exposed to agricultural climate shocks. In the Nordic shellfish kelp biorefinery, high-precision drone-based sensors are revolutionizing aquaculture. These units perform continuous monitoring of the water column to track critical environmental variables. By measuring real-time fluctuations in nutrient density and water temperature, the system creates a dynamic environmental map. This data is processed at the central refinery hub, triggering automated harvesting adjustments. This process optimizes yield and ensures farm resilience against changing ocean conditions. Traditional land-based agriculture faces immense pressure from climate instability, soil depletion, and drought. These vulnerabilities make our global protein supply chain inherently fragile. Vertical ocean farming de-risks this system by moving cultivation into the water column. This three-dimensional blueprint creates a climate-resilient foundation immune to the environmental challenges of terrestrial farming. By diversifying into the ocean, we bypass the exhaustion of arable soil and eliminate dependency on freshwater irrigation. The result is a consistent, predictable, and de-risked supply of protein for the global economy. Marine biomass offers a nutritional complexity that far exceeds traditional land-based monocrops. Beyond its high-quality protein, kelp and shellfish are dense with essential micronutrients. Iodine, crucial for thyroid function, is naturally abundant in kelp. Omega-3 fatty acids, often difficult to obtain sustainably, are heart-healthy staples in bivalves. Zinc provides essential immune support, creating a diverse nutritional profile that sustains human health more effectively than grains or soy alone. By integrating these marine sources into our diet, we move beyond simple caloric intake toward a truly functional, nutrient-dense global food architecture. We have transitioned from an era of scarcity to an era of abundance through technology. The blue economy is no longer a concept. It is the structural backbone of the modern global food system. By transitioning to a vertical water column cultivation, we have decoupled growth from land dependency. The blue economy now operates as the bedrock of our climate-resilient supply chain. This structural backbone ensures that our food system is no longer vulnerable to terrestrial climate shocks, marking the final stage of our food security evolution. Consumer hesitation was a major hurdle. People initially viewed marine proteins as mere substitutes. The industry overcame this through culinary transparency and strict labeling. By treating seaweed-based proteins as premium functional ingredients, we saw adoption rates accelerate significantly throughout 2025 and 2026. Vertical ocean farming represents the necessary evolution of human survival. By merging robotics, restorative biology, and global demand, we have ensured a stable food future for a world of 9 billion people. This model of 3D cultivation serves as the blueprint for our future. We are no longer limited by horizontal landmass. We are empowered by the vertical abundance of the sea. The transition to a blue economy is complete, proving that innovation can restore the environment while providing for all.